All right, problem number 4. So let's actually go ahead and take a look at this. We've got a person at rest on a cliff, so that means v naught is going to be 0. We've got a time of 2.5 seconds, and we've got an acceleration of 10. We want to know how tall the cliff is and how fast the person is going when they hit the water. So let's just draw this situation to begin with. So I'll make my initial position 0, because they don't really tell me what it is, and I can just assume that, since they didn't tell me the final either. V naught is 0. I know my acceleration is 10 meters per second squared. And I'm going to start labeling units here. My landing distance, or whatever you want to call it, where I hit the ground at, that's unknown. And then my time is 2.5 seconds. Now what I'm going to do is, I noticed people solving it didn't do this, but I'm going to kind of overkill this. I'm going to write down every equation and plug in the numbers. So I know x final is 1/2 at squared plus v naught t plus x naught. V final is at plus v naught. And v final squared equals v naught squared plus 2a times x final minus x initial. Now what I'm going to do is I'm just start plugging in numbers. So I know x final is going to be 1/2 times 10 times 2.5 squared plus 0 times t plus 0. And then I'm going to actually go ahead and calculate that out. And when I get that, x final is going to end up being 31.25 meters. Now let's go back and get the time. So v final is at plus v naught. The other thing is I don't know what v final is. That's the other unknown, so I should have written that down. So I have v final equals 10 times 2.5 plus 0. And so I'm getting v final is, in fact, 25 meters per second. Now let's be clear on something. Let's make sure we've actually solved what we asked for. They asked us how tall the cliff is, and I got that this final distance down is 31.25 meters from the top. So it's kind of logical that I traveled a distance of 31.25 to hit the water, so that tells me the cliff height is 31.25 meters. Similarly, I've got the speed of 25 meters per second, and that's the answer to number 4.